Okay, just as a review before we get to the problem we were trying to solve at the end of the probability lecture. Problem 11 stipulated that you had a bag of 10 coins, 9 of which were completely normal with a head and a tail, and 1 coin out of the 10 that was a two-sided coin. It had 2 heads. And the question we were trying to answer is, you randomly pick 1 coin out of this bag and you flip it 5 times, and we want to calculate the probability of getting 5 heads in a row. So how do we solve this problem? Well, the first thing you want to do is figure out what is the probability of picking each of these kind of coins. So the way that is written is the probability of picking a normal coin will equal 9 out of 10. There's 10 coins, 9 of them are normal, so your probability of picking a normal coin is 9 times out of 10. What is the probability of picking a two-sided coin? Well, there's 10 coins, there's only 1 two-sided coin, so the probability of randomly picking one is 1 out of 10. Okay. Then we want to find out the probability of getting 5 heads in a row having picked one of these 2 coins. So the way that is written is, what is the probability of getting 5 out of 5 heads and the probability of picking the normal coin, or what is the probability of getting 5 out of 5 heads and picking the two-sided coin. The total probability will be the sum of either getting 5 out of 5 heads picking the normal coin or getting 5 out of 5 heads picking the two-sided coin. If we're trying to answer the question of the probability of getting 5 heads in a row, what we would need to calculate is the probability of getting 5 heads in a row if we pick the normal coin, added to the probability of getting 5 heads in a row if we pick the two-sided coin. We don't know which one we're going to pick. So let's divide this into 2 arms. What is the probability of getting 5 out of 5 heads if we pick the normal coin? Well, the way we write that is, what is the probability of getting 5 out of 5 heads and the probability of picking the normal coin? On this arm of the study, what is the probability of getting 5 out of 5 heads and the probability of picking the two-sided coin? So we need to calculate both of these probabilities. Let's look at the normal coin. What is the probability of getting 5 out of 5 heads given that we picked the two-sided coin? Well, the way that is written, what is the probability of getting 5 out of 5 heads and picking the normal coin? That will equal the probability of picking the normal coin times the probability of getting 5 out of 5 heads given that we picked the normal coin. Likewise, in the other arm of the study, what is the probability of getting 5 out of 5 heads and the probability of picking the two-sided coin? That will equal the probability of picking the two-sided coin times the probability of getting 5 out of 5 heads given that we picked the two-sided coin. Okay, this is just basic probability. So when the experiment happens, one of 2 things happen. You put your arm in the bag, you pick a coin. Either you pick a normal coin or you pick a two-sided coin. We know because of the count, the probability of picking a normal coin, there's 10 coins, 9 of them are normal, so the probability of getting a normal coin is 9 out of 10. There is one two-sided coin, so the probability of picking a two-sided coin is 1 out of 10. So now we know the probability here of picking a normal coin or the probability of picking the two-sided coin or the normal coin. Let's look at the top arm of the study. We picked a normal coin. The chance of doing that is 9 out of 10. And then we flip this coin 5 times. And we get 5 heads. So what is the probability of this part of the experiment? Well, we know from the lecture that it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2, or it's 1/2 to the 5th. So this part of the probability is 1 out of 32, 1/2 to the 5th. This part of the study is 9 out of 10. So the probability of getting a normal coin is 9/10, and the probability of getting 5 out of 5 heads having picked the normal coin is 1/32. So we multiply these two things and we get 9 out of 320. So we know this arm of the study, the chances of getting 5 out of 5 heads with a normal coin times the probability of getting the normal coin is 9 over 320. Okay, on this arm of the study, what we want to know is what is the probability of getting 5, flipping it 5 times and getting 5 heads. What is this probability? Well, it's a two-sided coin. You can flip it 1,000,000 times. You're always going to get heads. So this probability on this part of the study is 100%. You're always going to get heads here. So the total probability of this arm is the probability of getting the two-sided coin times the probability of getting 5 out of 5 heads having picked the two-sided coin is simply 1/10. You're always going to get 5 heads, so that's a 1. 1/10 times 1 is 1/10. So to add these together, the total probability of getting 5 out of 5 heads, regardless of which coin, is going to be 9 3/20ths plus 1/10, and that will equal 9 3/20ths plus 32 3/20ths, which will equal 41 over 320. So the chance of blindly picking a coin out, flipping it 5 times and getting 5 heads, the chance of that happening is 41 out of 320. Looking at this a little more abstractly, if you look at any of these formulas, for example, let's say the bottom arm of the study. So you have the probability of getting 5 out of 5 heads and the probability of picking the two-sided coin is equal to the probability of picking the two-sided coin times the probability of getting 5 out of 5 heads having picked the two-sided coin. So to prepare you for understanding the Bayes theorem, let's say this is A and this is B. So the probability of B and A will equal the probability of A times the probability of B given A. So this is the start of understanding how Reverend Bayes actually figured out conditional probabilities. The probability of an event happening that is dependent on another event happening. So start to think about how this nomenclature relates to a coin, and it's easier to understand. Next, we'll try to demonstrate this graphically to get a graphical sense of what we're actually doing.